କେତେ ଭଲ୍ୟୁମ୍ ପ୍ରଡ୍ୟୁସ୍ ସେଲ୍ କଲେ that is not an outcome indicator.
Hello everyone. Good afternoon, one and all. Am I audible?
Yes, sir.
Okay. So shall we start or will we wait for some time?
Start for them.
Okay. Okay, now the screen is visible.
Yes, sir.
Okay. So this paper is basically about your GIS and GPS and the global navigation system. I think I missed a class on Friday. So I will be starting with block 2, and if they form it, then I will take an extra class to complete the global navigation satellite system. So we'll be starting with the fundamentals of geographical information system. I think in if someone of you who has done his or her graduation from in geography, then you might have studied about GIS and remote sensing. So the fundamentals of GIS and remote sensing, I think you know the definition of GIS and what are the different how it is really useful in contemporary times. So we'll be starting with the definition of GIS, then different data models and the database structures. So the data models, I think in block 3, it has been explained really well. So we'll just introduce the topic of data model, and then we'll be seeing in description in block 3 maybe tomorrow. So what is GIS? No, it is really, I think anyone who have already studied remote sensing and GIS in graduation times.
No, sir.
None of you have studied GIS and remote sensing. Actually, I need your opinions now, because unless and until I do know now whether you have studied or not, then now, because if you have already studied, then I will simply skip the simple bits, or else I will simply start from the scratch. Now, if you don't know, then please tell me. You haven't studied GIS?
No, sir.
Okay. Okay, we'll start from the scratch, and we'll try to understand what do we mean by GIS. So, GIS is basically a computer-based system. As you, anyone? Okay, so as we already know what a computer is all about. It is having different components. It is helping us in different ways. It is helping us in different applications. So just like other just like these kind of computers, GIS or geographical information system is basically a computer-based system that helps us analyze different geographical data and interpret, even manipulate different geographical data, so out of which you can interpret different things. I mean, you can take decisions out of it. And let's suppose now, whatever you are seeing right now, let's suppose you have a map right now. So map is basically a geographical data. Now you are seeing different geographical data within the map. So just like roads, land use, land covers, water bodies, then let's say a forest cover. So all these are basically geographical data or geographical informations. So these are basically represented by the computer system, so which is basically your GIS. Now, in simple terms, no geographical GIS is basically your geographical information system, and it's basically a system that allow us to capture, store, manage, analyze, and visualize different spatial data. So it basically helps us understand where things are and how they relate to each other in space. Now, in geography, the concept of space really holds an um important concept of geography. I mean, space in geography. So which can be defined by this geographical information system, and it actually helps to integrate the space with us. Okay, so it actually helps us to understand the space in a better way. So that is what GIS is. And then we can go through an example, just like imagine you do have a map, just a simple paper map. Now it basically shows what a location, maybe roads, rivers, and cities. But what if you wanted to know more than just location? Now, what if you needed to analyze the flood prone areas? Now, where basically flood occurs during monsoon or post monsoon times, and you really wanted to track the urban expansion on a temporal, spatio-temporal platform. Or maybe you wanted to find out the best route for emergency response. I mean, just like in Bhubaneswar right now, during evening hours the traffic is really very high. So if you want to find out a route so which will be suitable for emergency responses, then you can do it using GIS. So simply using a paper map that cannot do these kind of tasks. Okay, so that is where GIS comes in. Now, GIS is much more than just a digital map. So it basically combines maps with data that allow us to perform complex analysis and make informed decisions. So it's used in a lot of spheres, in a lot of dimensions, in taking start from the urban planning, disaster management, agriculture, land use, land cover, now even predicting or forecasting climate. So all these kind of things are basically done using GIS. Okay, so I think we have discussed about what is GIS and what is geospatial data. Geospatial data is basically uh, anything that do have a spatial connection. I mean, space or space is basically a region in geography. If you have studied regional geography, then you will understand what space means in geography. So space is are basically the places um, around the globe. So geospatial data is basically the data which are relating to those spaces. Okay. So what are the different components of GIS? No, different components. There are basically five components of GIS: hardware, software, data, people, and methods. People are basically the users of GIS. What do you mean by hardware? Hardware is basically, in computer systems. I think you might have already studied about the IT, information technology. Now, where you have already studied about hardware and softwares. So the same kind of hardwares are basically used for GIS. I mean, geographical information system. You will be requiring monitor to see different kinds of data. You will be requiring different storage devices to store different information or to store different data types. Then you may be requiring different servers, so where you can actually host different data. So all these are basically hardwares. I mean, just like different online datas are basically extracted from NAS. I think NAS. I think you know or not. I don't know actually, but it basically provides you a platform where you can host data at online platforms. So just like that, just like computers, all the no the keyboards that you are using, the mouse, CPU. So all these are basically your hardwares. So hardwares are basically used, and these are basically components of your GIS. So from the basic level, hardware basically includes computers, servers, storage devices, where GIS softwares run and data is processed. But it's just more than a computer. No, for large scale GIS applications, we need high performance machines with powerful processors and ample memory to handle big data sets and complex analysis. So other components can be your GPS devices. So that basically helps you collect real-time location data. Then drones and satellites. So they gives you high resolution imagery, which are basically input for the geographical information system. I mean, where from the GIS will get the data. So basically, remote sensing, just like GPS, drones, and satellites. So all these are basically different parts of the hardware or different components of GIS, and different types. Now these basically provides you data. Then plotters or printers are also used. You have different input devices where we may extract some information. I mean, you may require storage devices like SSDs or HDDs. So all these are basically different components of the hardware part. So these are basically examples. I mean, digitizers, scanners, disk drive, plotters. So all these are the hardware component of the GIS. Then comes the software module or the software component. So software basically allow us to create, analyze, and visualize spatial data. I mean, I think you guys have already no using computers. So where, let's suppose you are using Microsoft Word, or let's say PPT, Microsoft PowerPoint presentation. So where you are creating a document, you do have different you do have different functions uh, that is to be performed using different functions. Sorry. So likewise, GIS do have different softwares. I mean, the MS Office itself is a software. So where you are performing different tasks, using different functions and using different modules. I mean, Word, MS Word is giving you different type of services. I mean, MS Excel, okay, Microsoft Excel is giving you different types, other kind of services, where uh, PPT also gives you other kind of so all these are basically different modules or different softwares. And it just like in computers. Now some of you might have already used Photoshop, or maybe Adobe Illustrator, maybe Canva. So all these are basically different softwares. So likewise, in GIS there are different types of softwares, so which can handle both the spatial data and non-spatial data. So within the data module, I will be discussing about what do you mean by spatial data and non-spatial data. So GIS, some of the most commonly used GIS softwares are basically ArcGIS, QGIS. Then you have NV, ADAS, Imagine. So most of the popular softwares are basically ArcGIS and QGIS. Now because ArcGIS is widely used, and but it is basically a proprietary program, and that is why it limits different users. I mean, now you can simply install ArcGIS. Now although all of us are actually using ArcGIS, using sorry, uh, we are using the patched version. I mean, that is not a licensed version. So when you are not using a licensed version, there can be different types of problems. I mean, my MacBook doesn't support ArcGIS natively. I mean, the ArcGIS Pro is now right now they are giving a version for Mac, but natively QGIS, Mac supports QGIS, so that is why I do have QGIS. I will be giving you a demo on QGIS. Okay, so if you want, then I can go through QGIS and I'll show you now what do we mean by data, and what are the different data modules. When we'll be discussing about the data modules, I'll show you what do we mean by raster data, vector data. So these are the two most popular GIS softwares right now. You have ArcGIS and QGIS. Now ArcGIS is a proprietary program, and you need a license. I mean, you need to purchase a license to use ArcGIS. But QGIS is basically open source, and you can use it freely, and it is available freely. So you can install QGIS in your computer, and it basically requires different computer languages. I mean, softwares, these are the softwares, they do use different computer languages. Now if you are familiar with different computer languages, just like Java, Python, C++, and other languages, then these GIS softwares basically use these kind of languages, and SQL also. I mean, spatial SQL, and so all these kind of computer languages are basically used by these softwares. And if you know Python, I think um, most of us are not that technical. Anyone who knows Python? Nobody? Have anyone ever used Python, or maybe R Studio? Okay. So hoping that you may not have already now you might have heard about these kind of computer languages, but I believe you may not have already used it. Okay, so these are the computer languages which are basically used by the GIS. I mean, actually, this module, GIS and remote sensing, it requires a lot of classes to be completed. I'll simply go through what are the important points only. Now, because I can't cover all the things within 2 hours or within 4 to 5 classes, so it will not be completed. So I will simply go through the important topics only. Now, although fundamentals are very important here, so I'll focus on the fundamentals only. So what do you mean by GIS? I think you have already understood it. GIS is basically a computer-based system, so which helps us, visualize, analyze, and manipulate the spatial data. Not only spatial data, even non-spatial data can be analyzed using GIS. Okay, so there are different components. So what are the components that we are basically discussing right now? So first one is your hardware, then comes your software. So within software, we have discussed about different examples of softwares just like ArcGIS, QGIS. You have Beta, Simacin, NV, and Saga. Then Grass GIS is also available, and and right now the current trends or recent trends are basically on cloud-based GIS. Okay, so cloud-based GIS, just like one of the best examples are basically your Google Earth Engine. Now, Google Earth Engine is widely used right now. So it basically uses Java scripting. So it will be requiring Java scripting to use Google Earth Engine. So if you don't know, it will be really difficult. Or you can simply use AI to use Google Earth Engine. I mean, you can use different co-pilot models or maybe ChatGPT or DeepSeek to use the Earth Engine features. Okay, so these kind of softwares, I mean, just like MS Word, so you can perform different tasks in MS Word offline, but Google Doc also provides you similar kind of features online. I mean, if you do have an online platform and natively you don't have the Microsoft Word, then you can also process the Word document. So just like that, GIS, these kind of GIS softwares are basically a standalone desktop versions of GIS. Now, while cloud-based GIS is basically just like the Google Doc. Google Earth Engine provides you different types of data there, and one can simply make use of it to perform or to take any decisions. So what GIS softwares basically do? GIS softwares provides tools for layering maps and running different statistical analysis, even spatial analysis. You can perform different 3D modeling or even predict future trends. Now, because nowadays machine learning is really popular. I mean, different machine learning models and deep learning models are basically used in GIS for any kind of tasks. Now, I think you know about linear regression. Now, because linear regression is the fundamental of machine learning. So whenever you are using any kind of linear regression models, so what basically you are saying, it basically predicts something. It predicts a line, so it which help us to analyze the future trends. So that is how linear regression is used. Now, although there are different types of machine learning models that is basically being used right now, Now, just like supervised, semi-supervised, and unsupervised machine learning models. So now, whether or not you have heard about random forests, support vector motions, then extreme gradient boosting, light BZM. So all these are different kind of machine learning models. So which are used in GIS, performing different tasks. Then what do we mean by data? I mean, in GIS, data is no data models that will be looking into it. So data is basically the input into the computer system. So that is what data. Now, data can be of two types. One is your spatial data and another one is your non-spatial data. So spatial data basically represents the location features on the earth surface. So it include features like points, then polygons, or maybe different lines. And a point, line, polygons are basically uh, different properties of your vector data format. So first, spatial data basically represent any feature within a location or within a space. I mean, the space component is a mandatory here. I mean, it should belong to a space or any region. I mean, all the roads or cities or different kind of physical features which are available. I mean, that equatorial regions do have this. So equatorial, whenever you are saying equatorial region, so it is basically a space component, and it is basically describing about the spatial phenomena. So where in geographical thought you might have already studied about the spatial organization. So the GIS basically helps us um, understand those spatial organizations or understand those spatial phenomena in a better way. I mean, now right now you are using Google Map services. You can use Google Satellite. You can also look into the Google Satellite image, now where it basically gives us information about different types of physical features which are available, and different types of you know now you want to identify which are the settlements within the space. You want to identify which are the water bodies within space, and you want to analyze something out of it. So then you will be requiring GIS. So data is basically what? So data is basically either you are using remote sensing data or survey data. But data is any imagery can be a data. I mean, if you do have a map and you want to use it to analyze something, then that can be a data, or any kind of input that can be given to the system. So I think I have told something about the spatial data. Now, while non-spatial data do not have any kind of spatial organization or spatial phenomena. I mean, this is basically an additional information or metadata. Okay, so about those features, I mean, there can be cities. So cities do have different kind of metadata. I mean, different kind of additional data, so which can be available to us. I mean, um, just like population. Okay, so population within the city, so that is basically an attribute data. um, so data input, I mean, how we can use data input here. I think within this schematic it has been given using keyboard, digitizer, mouse, or scanner. So the data input can be done. Then storage and management, data storage and management. So we'll be using the database management system, and within GIS there is a database management system. Just like in our computers, we are dividing the main system storage into different sub stories. Like, if you are using Windows, then you are partitioning your drives. Okay, so C drive, D drive, or E drive. So likewise, then categorize now which are the different drives that I will be using for. C drive is basically reserved, and where most of the softwares are basically installed. So now let's suppose, out of your 512 GBs of SSD, you have partitioned into three categories. Now where you the other two, other than the C drive, other two can be used for different other purposes. You can use one for education and use another for entertainment. So so this is how you are managing your database. I mean, then what you are basically doing there, now you will be you'll be finding some PDFs, you'll be finding different video presentations. So so that can be included in your education drive. Okay, so this is how you manage different files. Then within entertainment, you are basically downloading different movies from different online sites, and you are storing it there, and you are using it so whenever you require it. So that is how you are managing your data. Okay, so this is what storage and management is all about, even within GIS environments. So within GIS softwares, so we will be using some kind of storage. So now whether you are using SSDs or SDDs, uh, then different types of formats are basically used. Now just like within video formats, you can can some of you can give examples of video formats? What are the different types of video formats? You can type in messages also. Anyone is there or not? I'm asking Prasanna Kumar Misra. I'm asking actually, what are the different types of video formats? Okay. Just like different types of video formats, you do have different types of formats in GIS environment. I mean, different vector formats do have different file type, just like dot Safe file. I mean, safe file is one of the most popular vector formats. Then dot TIFF or TIF is one kind of raster format. So which is widely used. I mean, right now the geo database. So uh, geo database is really popular right now. It gonna replace SEF files now, because SEF files do have different types of metadatas available. So maybe that will be outdated after few years, the SEF file kind of formats. Now a different raster formats, TIFF, even image formats, all the image formats. Then so those are basically your different raster formats. So at the end, we do have data output. So within data output, what happens? You will be giving some information now, where some input, sorry, some input will be given. Then you will analyze something or interpret something, or maybe you'll manipulate something. So out of which you you can understand something. I mean, so that is what data output is all about. I mean, you can simply print uh, uh, a hard copy for the map that you have already prepared, or even you can store it in digital formats. So that is also fine. Then the people component of the GIS. So people are basically the users. So users know what now why computers are there. Now if nobody gonna use it, then the computers are of no use. Now just like that, GIS is itself a computer based system. So people are basically here to use it. So people are the end users. So they're gonna use it. So that is why they are part of the component. Without users, the whole ecosystem is you know uh, so I mean, without people, uh, this is there will be some that will be of no use. I mean, even though there will be computers, it will be of no use if we will be not using it. So people can be of different categories. I mean, there can be viewers. So viewers are basically all the people who have no idea about the design and development of GIS, but they do use different types of maps. I mean, all the general mass or general people, so who are using some kind of maps to uh, so they are basically the viewers. Then you have general users. So the people who basically use GIS for general purposes, just like business or professional services or decision making processes. So these are basically general users. I mean, some of you might be using Google Map services, GPS services. So you are basically a general user now, because you are using a product of GIS. Okay. So even different entrepreneurs or administrators, different planners, uh, they do use GIS. So they are the general users of GIS. Then last one is your GIS specialists. Who are GIS specialists? So who who manage databases. They administer different databases. Then they are GIS. Just a minute, please. Okay, so then comes the GIS specialist. So these are basically those people who plan and develop different GIS softwares, just like different programmers, system analysts, and uh, dif- okay. Then methods. So GIS basically involves specific data collection methods, analysis techniques, and cartographic principles. So to accurately ensure, to ensure accurate results. Some of the common GIS methods basically includes remote sensing. Then you have spatial analysis, then geostatistics. So these are basically different methods that is being leveraged by the GIS to perform different tasks. So no, how it basically helps. So for collecting data, remote sensing is basically being used. I mean, the satellite platforms and the drones, airborne platforms or groundborne platforms, and the spaceborne platforms. So where uh, we these platforms are basically used for collecting different data. So this is basically a method. So this is basically a process. So this is how different techniques are basically engaged to collect different types of data, so about the space. Then within spatial analysis, so if you want to study the spatial patterns, I mean, you really want to know no where the density of road network is really dense or really high than the other region. I mean, take the case of, let's say, Cuttack or Bhubaneswar. Now, although Bhubaneswar do have a larger area as compared to Cuttack, but if you do have any doubt, where the road density is basically high, so then you can simply perform some kind of spatial analysis. So to perform different kind of spatial analysis, you can simply look into the road network patterns, then quantify the road networks, and understand what is the area and what is the length of the road network which is available in those regions. Then you can then only you can understand the density of road networks are basically higher in Cuttack or in Bhubaneswar. So only after analysis you can understand it. Now, having a random guess can actually solve some of the problems, but to to understand it in a deeper way, you will be requiring uh, different platforms to actually analyze those kind of problems and find some solutions out of it. So this is no, it's not only about understanding about uh, the road density. So spatial analysis can be done to understand other things also. I mean, you can look into the climate change phenomena. Okay, so which are the basins which are more vulnerable towards climate change, and which are the drainage basins or river basins in the world or over the globe, so which are facing higher climate change impacts. So that can be studied using different satellite imageries or satellite data, so which is basically providing you uh, data regarding rainfall, temperature, soil moisture, evapotranspiration, air pressure. Okay, so all these kind of data are available to us from the satellites. So if we want to analyze something, then we need spatial analysis. So spatial analysis is one of the methods which are basically being used in GIS. Then geostatistics. So geostatistics is really helpful to understand now what are the different statistics which are available, now which can be helpful. I mean, if you are studying about land use and land cover of any particular region, okay, so then how what are the different changes that has occurred over a period of time. Now you will be requiring statistics, right? I mean, let's suppose vegetation covers were basically cleared to to make buildings. I mean, the built up regions are basically increasing over a period of time. Okay, so let's take the example of Bhubaneswar. The satellite data, I think, is easily available from 1984, the Landsat data, and before that up to I think 1972 or 1973 data is also available um, over USGS Earth Explorer. I think you can register yourself and download those satellite data. Here, we are basically discussing about the example of Bhubaneswar. So the land use land cover changes is massive in cities like Bhubaneswar. Now, why? Now the trends of urbanization is really high. It is in a very progressive manner. So we cannot simply now to quantify it. Now what was the percentage of vegetation cover before, let's say, 1990 or 1980, but right now what is the percentage of vegetation which is available to us, and no, how much vegetation has been lost over this decades or over this period of time. Now, so to quantify that, you will be needing geostatistics. Okay, so you can use zonal statistics, so which is basically a function of GIS. Then you have a raster calculator. So all these kind of things, or even different queries are basically run for the vector formats. Vector formats where you can get information regarding length, area or perimeter. So all these kind of information is available to us using this geostatistics. Okay, let's have a break, then we'll continue.
Sorry, sir.
Okay, Prasanna.
Sir, actually, sir, we have a problem that, sir, we are in teaching profession.
Okay.
So the class hour is something awkward that we are not unable to attend such type of interesting and serious classes. Actually, we have not a trace of idea regarding this GIS and QGIS or remote sensing like that.
Okay.
But the schedule that has been decided by the RC Bhubaneswar is 4 to 6 p.m.
No,
But
you can actually I think you can request them to shift the timing. Even I am an assistant professor in an university. Okay, so even my time is not permitting to take your class during these hours. I mean, I do have practical classes. I have shifted my classes um in the morning, and then I scheduled this class. So it is also difficult for me. I mean, I have
no, no,
also
sir,
requested
sir,
you
actually,
can.
I just take a favor from your side that in the during the class hours of the 4 to 6 p.m.
Okay,
actually I just try to uh, as a group we can place a request towards RC Bhubaneswar. That is the another thing, but that is my problem, sir. So during your classes, if I am unable to respond your any questions, or so that should be pardoned, sir, because I just put all these classes in the recording mode so that in my feasible time I can be watch particularly these videos for the better ease and understanding. So this is the problem, sir. If you can allow me.
okay. It's okay. I do understand. I mean,
Yes, sir.
if
Because we are just pack up to 5 p.m. And before that, we are not permitting for any kind of these things during the school hour. So I just put all these classes in a recording mode, sir. So
okay, it's no.
certainly not responding your sir asking questions. So that is the issue, sir. If you can take just kind of favor.
Okay, I do understand. I do understand. No, no, why? I think a lot of people have registered under the IGNO for this program. I mean, there are only 8 to 10 people who are joining these classes. I mean, I do understand that a lot of people they are engaged in different kind of services, or else they could have gone for the regular courses. So I do understand that. It's okay.
Thank you, sir.
Okay. So let's have a break for 5 to 10 minutes. So then I will continue.
Sir, one more thing, if you don't mind, sir, I just get your number, sir, contact number.
Uh, okay. You can find me. Um, you can mail me actually.
Yes, sir.
Okay. You can search me in the Google Tapas Ranjan Patra. So under Rajendra University, you will get my profile. Or
Rajendra University.
I'm giving you my mail address here. Okay.
Thank you. Because this particular unit is very important for us. We are not getting some kind of information. So that's why, if in case any doubt, we can just simply contact you.
Okay.
Okay. Thank you.
So I have given my email in the message box. You can have a look and save it. Or
Thank you, sir. Thanks a lot,
yeah,
sir.
you can write a mail to me, no issues. And if you really required to know something, and you wanted an interactive session, or you really wanted to know something about GIS or remote sensing, okay, so you can call me. But first of all, you need to message me or get me a mail. And if I think that is important, then I will give you my contact number.
Sure, sir. Thank you, sir. Thank you, sir.
Okay, you are welcome. Okay, so let's get started again. I think we have discussed about the definition or the introduction to GIS. What are the different components of GIS? Now we'll be discussing about the elements of GIS. Elements are basically your geospatial data, data acquisition, attribute data management, then data display, data exploration, and the data analysis. So these are the different elements of GIS, and these are basically prescribed syllabus of for you only. I mean, the elements of GIS can be more than this. Okay, so let's try to understand what do you mean by the elements, different elements of the GIS. Geospatial data basically refers to any data that has a geographical or spatial component. So it basically tells us where something is located on Earth. No, this data can come in several forms. I mean, point data, line data, or polygon data. So in raster data, spatial data models and non-spatial data models, I'll take you to the QGIS and I'll show you what are the point, line, and polygon features. Point data is basically relating to any point. I mean, where is the post office uh, within a place? So that is basically a point data. So, that will be having a specific latitude and longitudinal information, so that is basically your point data. I mean, location of a tree, location of a school. So those are basically point data. So which are the line data? So line data are basically any single line or singular line kind of data. I mean, the road networks. So road networks can be represented in line data. Then you can have rivers also. Okay, so rivers, roads, or pipelines. So all these are basically your line data. Then what are the polygon data? So polygon data, uh, any areas or anything that is basically represented by area or boundaries. So that will be called your polygon. I mean, if um, we we are talking about any region, let's say Bhubaneswar, so it will be having different words. So including all the words, so um, Bhubaneswar has been constituted. Okay, so it will be having a boundary. I mean, so that is basically a polygon data. Okay, so geospatial data is typically paired with coordinates. I mean, like it will be having latitudes and longitudes. So to tell us exactly where these features are located, so that is why latitudinal and longitudinal informations are basically used. Then data acquisition. So data acquisition can happen in several ways: through remote sensing, through surveying, through existing maps and databases. So here I think different examples or sources has been given, like satellite images. Satellite images are basically remote sensing data. Now, where different satellites do provide us different data. I mean, in remote sensing, I think you do have a paper on remote sensing where you'll be studying about the electromagnetic radiation, the spectrum, then what are the different types of data which can be, which is basically being provided by remote sensing satellites. Okay, so you do have visible bands, you do have infrared bands, you do have microwave. So even microwave remote sensing is right now really popular. You have different types of remote sensing, just like active remote sensing and passive remote sensing. So all these remote sensing satellites or even other platforms, they do provide different data. So data acquisition can be done through satellite images. Then you can use topo sheets or paper maps, then GPS or surveys. So all these can be used. Then and what is the primary goal of data acquisition? The goal of data acquisition is to gather most accurate and up to date relevant data for no any kind of GIS projects. So keep in mind that data acquisition can be time consuming, costly, or even it is really challenging in some cases. Um, Now, if you really want to analyze, let's suppose, the soil data of um, the whole of India, and you want very um, very high accuracy. So for that you need to now you need to do what? You need to collect different soil samples, then send it to labs, and then only you'll get some results, I mean accurate results. Or else there can be different other ways. I mean, you can use simply satellite imageries. So different satellite imageries, different bands that actually gives you information regarding the soil properties. Okay, about the soil properties, the soil texture, and different other characteristics of the soil. So that can also be used. In some cases there can be different problems. I mean, if you really want to, let's say, validate the data for a very large region, and you have used remote sensing or GIS datasets to interpret or to analyze something, then it becomes really difficult. So that is why data acquisition in some cases becomes really difficult. Okay, and it is really time consuming. That is that we already know. Survey, if you are doing some extensive surveys, then it will take uh, ample of time, and it is really expensive also. Then you do have attribute data management. Attribute data management is basically non-spatial information, and it describes the features in geospatial data. Now, for example, if you have a point that represents a school, the attribute data might include informations like the name of the school, the number of students, the year it was built. So all these are basically attribute data. Managing attribute data effectively is really critical or really important now, because it helps us analyze and interpret the spatial data. Now, these are basically metadata which complement the spatial data. The spatial data, let's suppose the point spatial data is basically a school. I think I have given an example. Now, which are the metadatas again? Most of you people are basically engaged in different schools or maybe different colleges. So that point do have a latitudinal and longitudinal extension, and that can be shown as a point data. So within that point data you can include different attribute data. Different attribute data can be name of the school or name of the college. Now, how many teaching faculties are there? How many non-teaching faculties are there? So all the characteristics of that school or properties of that school can be included as the attribute data. So that is how spatial data and attribute data are different. They don't have a locational information exactly. Now, just like schools, they do have a space component. Now, because schools or colleges, they are occurring spatially. They are basically spatial phenomena. Okay, so these are attribute data, and this can be managed using database management system of GIS, geographical information system. And here the common models are basically tabular, hierarchical, network, relational, or object oriented. So I think it is really difficult to go through all the common models, but I can show you the tabular model in QGIS. what attribute data means. Okay, so here, okay, so this is basically the geomorphological information on Balangir district. I have tried to show the whole of KVK district that I am working on, but I couldn't able to find it. Okay, so here, you can look into different colors, so which are basically representing different polygons. So let's suppose this pinkish color or pink color is basically showing you something, and the brownish color is basically showing you something, the greenish color is basically showing you something. So this is basically a polygon data. Okay, so all these are basically polygons. Now if we'll get into the attribute, okay, in tabular format, so we do have a feature here in open attribute table. So you can simply open it and look into different object IDs. Okay, different object IDs or different object ID. Here object IDs are basically polygons. So polygons are closed boundaries. Okay, so here you can look into this green area or this green region. So this is basically a polygon now because it is closed. Okay, so line is basically simple line. I mean point is a point data, but here we do have the geomorphological information in different polygons. Now if you can look into here, no, so this id or this region is basically representing water body, and it is a pond. Okay, so then you have information like pediment, so which is a pediment. Then you do have different other. Okay, so let's suppose residual capping, even residual heel, scarp, valley fill, ridge. So all these are attribute data for the geomorphology for the Balangir district. Now here, this is the whole of Balangir district, and within these polygons, different attribute data has been stored, or different type of data has been stored. I mean, if we will be going in detail, then we can have areas of different geomorphological features. Now, um, how much floodplains are basically available? So that can be an metadata, sorry, a metadata or an attribute data. Okay. Then data display. Now, once we have our spatial and attribute data, we need to present it in a way that makes sense. Now, this is where data display basically comes in. Data display in GIS is all about creating maps and visualizations that makes it easy for people to understand the data. Now, this could be anything from simple 2D maps, basically showing the locations of schools or colleges within a city, or to even a 3D map. I mean, that can actually show elevation or the land use patterns. So all these are basic, that can be a 3D map. I mean, now here we can look into the 3D aspect. Okay, I will be showing you how 3D aspects can be shown. Now, here the elevation, simple elevation can be presented using a color ramp. I mean, these colors are basically representing these groups. So the lowest elevation is around 125 meter, and the highest elevation is around 993 meters. So here the color ramp itself is presenting, which are the areas which are representing higher elevation areas, and which are the regions which are basically low elevated regions. So these regions are basically low elevated regions, and these are the high elevated regions of Balangir district. So if you really want to have a 3D view, or I'm just for the sake of presentation only, I will create a hillside map for the Balangir district. Let's see how it goes. Okay, so here now you can visualize the 3D aspect of the elevation of Balangir district. Now you can clearly clearly differentiate between the areas which are highly elevated, between the areas which are low elevated, or so these are easily visible here. When you are adding any 3D aspect into the map, so it creates easy visualizations. So GIS basically allow us to customize the data. Okay, and how the data is basically displayed using different colors or symbols or levels. So to highlight specific features or trends. Now, well-designed data display helps make GIS insights clear and really actionable. I mean, if you have analyzed something, and you can give a different insights, then that should be actionable. I mean, I have studied on the groundwater potential zones. Now, if I do have some policy implications that I can really address, so government can take different steps to construct different artificial recharge sites in different regions. So so GIS basically gives you that platform now where you can analyze different spatial phenomena or different spatial components, and help the policymakers, or help the government, or help the administrators to ease out the administration. Then you have data exploration. So data exploration is no that basically involves interacting with data to uncover different patterns and trends and relationships. So these are basically data explorations, I mean. And when you will be having some kind of raster data or vector data, so first you need to explore it. Now after that only you can analyze the data, I mean, you will be needing some processing before analyzing the data. Now for example, you might want to explore now where certain features are located, just like floodplains. Now, where these floodplains are basically located? Now, because the coastal Odisha is highly vulnerable towards flood. Now, Puri, Kendrapada, Jagat Singhpur, and so all these districts really, um, face problems of flood. So you want to explore, okay, where certain features are located, then how they basically relate to other features, then what trends exist over time. So these kind of explorations can be done using data exploration tools. In GIS, data exploration often involves selecting different features, clicking out on maps, and using tools that basically let you measure distance or view data in different formats. So this stage is basically crucial for developing a deeper understanding of the data before moving on to analysis. Okay, so now let's suppose you want to analyze uh, about the groundwater potential zones in Balangir district, and before analyzing that, you might want to uh, understand what are the different physical features which are available, then which are the regions which may have you know different higher groundwater potential zones. So first you need to explore the data, I mean, before getting into the analysis part. Now here, now let's suppose I have added one of the base maps of one of the base maps, that is basically Google satellite imagery. So here within Google satellite imagery, now we can have a look, I mean, these are basically the river channels. Okay, so these river channels are helping uh, different patterns, and helping in different things. I mean, the agricultural fields are basically supported by these rivers. Then you do have different ponds. Okay, and these are the settlements. This is really easily visible using Google satellite imagery. So here you basically gets an idea uh, about the whole thing before proceeding to your actual work. So that is the whole motive of it. Okay, the data exploration. Then data analysis. So data analysis involves basically using GIS tools, techniques to extract meaningful insights from the data. So this might include your finding patterns, like identifying areas so which are having highest population density, then predicting trends such as forecasting future land use changes. I mean, in regions like Bhubaneswar is really dynamic in terms of land use land cover changes now, because the built up index is really, moving very high. So that can be a region. um, you can simply put in a simple linear regression model or any machine learning model to predict the future. I mean, you need to understand what is the annual land use land cover change, what are the different types of changes that is occurring in Bhubaneswar. Now whether the vegetations are basically the regions which are basically covered by vegetation are basically reduced or basically getting diminished over a period of time, and the built up areas are basically increasing. So the rate of increase can actually predict the future built up areas. Okay, so that is how machine learning models are basically used or basically trained to predict the future land use land cover classes. So this is not only useful for land use land cover classes. So it can be used for forecasting or predicting a lot of things. I mean, the climate forecasting is basically done using different GIS tools, and this basically helps you understand the pattern. Okay, so then running different spatial queries means what? I mean, you want to know now within 20 kilometer of radius of your school, what are the different important administrative locations which are available. Okay. So how can you do it? I mean, if you do have a point feature, then you can simply buffer, add a buffer. So this is basically a spatial query in GIS. So buffer analysis, spatial overlay analysis, network analysis. So all these kind of analysis basically gives you insights, and for policy implications, different actionable insights. So that can basically um, that can basically guide you in decision making processes. Okay. I think historical development, you can go through it. I mean, this is really easy. And so the Canadian Geographical Information System was the first who basically conceptualized the Geographical Information System in 1971. And it actually started in early 1960s. And then different authorities or different organizations and different institutions, they came in and developed. Now this is basically a timeline that has been given in block 2. You can look into it, and when it was started 1963. So they basically, the Canadian Geographical Information System basically initiated, and the term GIS was basically introduced in that year. So right now in 2009 to present, so web-based and mobile applications, cloud computing, and integrating real-time features via Internet of Things had been developed. So right now, I think Internet of Things, basically IoT and ML, so basically used for machine learning. So all these are right now, these kind of things are basically getting really popular. I mean, the cloud based cloud computing or cloud based GIS platforms, just like I have given examples of Google Earth Engine. And then web based and mobile applications are also available. I mean, web based, so just like cloud based GIS platforms like Google Earth Engine can be web based. Then interactive maps, just like Kepler. I think Kepler is one of the web-based platforms which is providing interactive map features. So that can be really helpful. Then now here you can look into the development of QGIS here in 2009. Okay, Quantum GIS was developed. This is basically one of the open source um, GIS softwares right now, and it is really popular. Then what are the recent trends? I think recent trends, I think we have already discussed here from 2009 to present. Now, right now, integrating real time features. Now whether satellite images can be uh, easily downloaded to monitor flood within an affected region during post monsoon period or monsoonal period. Now, if let's suppose take an example of, let's say, Puri district. So the regions, now take an example of, let's say, Nimapada, or let's say Gop, or let's say Konar. So all these regions, let's suppose these regions are facing right now the flood situation. So can we monitor it real time? I mean, at this time, can we do it? Yes, we can do it. So this is how advanced GIS is right now. And the use of machine learning models, the use of cloud computing, use of cloud based platforms, web based platforms. Now right now different mobile applications are also developed to understand, and these are basically giving ample of dynamics into these are basically providing ample of dynamics into the GIS platforms. So, what are the different applications of GIS in terms of recognizing problems, visualize and monitor change? We'll be looking only into this now, because in a broader sense, the application of GIS can be very vast. Okay, so we'll be looking into the recognized problem. Now, how GIS can actually help you recognizing a problem. Okay, so by visualization also you can actually recognize different problems. I mean, um, you can look into different satellite imageries. Now, whether the forest patches are basically being cleared, then there will be some issues with the environment. So definitely there will be environmental degradation. So this is one of the problems that can be identified through the GIS. Okay, so different here you can look into it. Now highlights the recognized problems, basically highlights the set of spatially driven problems where maps are used to visualize current environmental issues, to emphasize solution and formulate policies. So that is what I have given example. I mean, if some of the regions where the rate of uh, the forest clearance is really high, so that is basically giving you a sign of environmental issue, I mean environmental problem. So that need to be stopped. So so you can simply visualize it, and you can simply recognize those problems very easily. I mean, if uh, in recent past, some regions do have already a very dense vegetation cover, but right now it is not having that dense vegetation cover. So that means you are you can actually see some sort of problems that may occur in future. So here, um, how we can basically recognize this problem? I mean, you can look into the satellite data year by year for a decade, maybe for 2 decades, or maybe for 3 decades. Then you can simply, analyze those data and recognize the problem. Okay, so that is what, GIS is helpful in identifying or recognizing different problems. So it also helps us to visualize and monitor change. And for example, now GIS is basically used to track forest loss by comparing satellite images over time, that I have given example. So this helps government and conservationists take action against illegal logging. Then another example can be, cities are basically growing very rapidly now. Okay, and GIS helps open urban planners to see how land use is changing and whether infrastructure needs to be adjusted. And this GIS can actually help uh, track rising sea levels, then shifting weather patterns and glacier melting. Then so this kind of insights uh, can be given to different scientists or different administrative organizations, so that they can take different steps to eradicate different environmental issues or maybe climate change issues. Now, there are different ample of studies which are available in different, very high reputed journals having high impact factor. So which are published, they are published regarding the coastline changes in Odisha. I mean, they have analyzed the data, satellite imageries, and the data for more than 30 years. So that basically shows, how the coastline is basically changing over a period of time. So that will give you information regarding what is happening, now, because the coast is basically very dynamic. So now, because it is interacting with the sea, um, and the dynamics need to be understood properly, or else there can be different hazard. Okay, it can bring different hazards to us. So also the sea level rise is also studied by remote sensing data. And GIS can be really helpful in analyzing different problems here. Then situational awareness, it means basically having a real time understanding of what is happening in a particular area. I mean, uh, just like the example of flood, just like, let's suppose in the Nimapada of Puri district is right now it is affected by flood. So situational awareness is all about understanding that real time happening within that particular region. So that is what situational awareness is about. Okay, so how GIS basically plays a crucial role in emergency response, even in public safety, and even in military operations also. Okay, so um, let's take the example of disaster management. I mean, during flood or during earthquake is really difficult. I mean, GIS basically provides real time data on affected areas, so that basically helps emergency responders, to provide direct resources where they are needed the most. I mean, if some people, they require some resources very badly in the affected region, in disaster affected region, then they can be easily given the service. um, I mean, this situational awareness is also used by the military operations. They do use GPS tracking devices, then other remote sensing devices. And then now let's suppose situational awareness here. One example has been given. The GIS generated maps are used to know the global spread of COVID-19 and suitable measures to be adopted to stop the spread of pandemic. I mean, GIS can actually help us map now which are the regions which are highly affected by the pandemic, okay, or the COVID-19. So this basically gives you a situational awareness. I mean, if the crime scenes has been mapped, okay, so few parts of Bhubaneswar has been shown that these regions are basically having high crime rates during night time. So you will be having a situational awareness that these are the places I shouldn't be visiting during night time. So that is basically situational awareness. I mean, GIS basically helps in that. Then establish priorities. I mean, GIS help establish which areas should be prioritized for action, and this is crucial for fields like public health, infrastructure development, and disaster relief. So all these are really crucial. We can take example of healthcare planning. I mean, GIS can really identify areas with highest disease outbreak, just like the pandemic COVID-19. So basically that helps the health departments to prioritize vaccination program or vaccination drives in those regions first. Okay, so then infrastructure development also, government use GIS to basically determine which roads or which schools or which hospitals should be built first based on the population needs. But right now in today's time, the uh, the political influence is having a greater role to play than you know prioritizing uh, now which of the regions basically requiring infrastructural development. I mean, some regions are really backward, but still no steps are basically being taken by the government. So this is basically a political scenario that is also need to be analyzed. Although if it is an emergency, then definitely GIS can help prioritizing which of the regions or which are the things that need to be taken care of first. To forecast the future scenarios, this basically helps to predict uh, the future. I mean, the flood prediction models that basically predicts now which are the regions which are highly vulnerable towards flood, and those regions need to be properly planned to uh, show some resistance against flood. So different models are there, and to identify trends and how GIS basically helps in identifying trends. GIS basically helps in tracking temperature changes, even the rainfall changes, and different weather patterns over a period of time. So that basically helps us understand the trend. I mean, now just like the built up areas in Bhubaneswar is basically showing an upward trend. So, and because only after analyzing the built up index using different satellite data, using the GIS platforms, then only we can quantify it or quantify the trend. Okay. So we'll be looking into the organizational aspects and the data models. We'll start with the data models tomorrow. Okay, thank you everyone.